Yep, here we go. We're going to go over question 5 from the 2018 AP Calculus AB exam. Bread and butter stuff here. It's a solid question. So here we go. Let's just get after it. Let f be a function defined by f x equals e to the x cosine x. And then it says find the average rate of change of f on this closed interval 0 to pi. All right. So as soon as you see the words average rate of change, you should be thinking slope of a secant line. All right. And slope of a secant line is the formula f of b minus f of a over b minus a. It's basically just change in y over change in x for a particular interval. All right. Now keep in mind, you might be thinking, wait, didn't you recently tell us something about average value and it wasn't going to be on the 2020 exam? Yeah, that was average value, Momos, okay, not average rate of change. All right, so this is on your test, so be careful with that. All right, so here we go. So let's just get after it. So m secant, right, it's going to be f of pi minus f of 0 over pi minus 0. All right, and so now how do you do f of pi? You check pi in the function f where you see an x, so that's e to the pi times the cosine of pi, and then minus, now chuck 0 in, e to the 0 times the cosine of 0, and then all over pi minus 0, which is just pi. So these guys in 2018 had to do this without a calculator. Technically, you're going to be allowed to use a calculator, and you also probably could have some of these trig values memorized or written down, I should say. And I can't imagine they're going to ask you a question where that's going to be tested on just because you have open notebook. All right, but let's pretend like you didn't have an open notebook. How would you do this, right? Hopefully you knew. Good friend, unit circle. All right, for whatever reason, we're so resistant of this. It's the easiest thing in the world, right? So the unit circle is a circle that has a radius of 1 unit, hence the name unit circle, right? So then if I look at these points here, remember it's centered at the origin. That is not a very symmetric unit circle, but you get the idea. All right, so those are the values. And so now I'll put the rotation on in red. This would be 0 radians up here at the North Pole. That's pi over 2. This is pi radians. This is 3 pi over 2. And then back coterminal with 0, which would be 2 pi radians. Okay, so those are the rotations. You have to remember that the x values on the unit circle, so all of these x values on this unit circle are representing cosine of some rotation, and the y values represent the sine. So if I want to do the cosine of pi, I go over to pi and I look at the x value. And so then the cosine of pi, I know that's going to be -1. If I want to do the cosine of 0, I go over to 0, I look at the x value, I know that's going to be 1. So now when I do this, -1 times e to the pi is just going to be negative e to the pi. I'm going to write it that way. E to the 0 is 1 times 1 is 1, so that's going to be -1. And then all over pi. And whatever this number works out to be, it represents the average rate of change of this function on that interval. All right, so standard issue stuff there, bread and butter. Let's rock and roll. Let's get to the next question. It says, what is the slope of the line tangent, all right, to the graph of f at x equals 3 pi over 2? All right, so bread and butter again. I mean, I keep saying that, but slope of the line tangent, my goodness, that's what we did in the first month. Right, that's just find the derivative and plug the point in, right? So it couldn't be any easier. So now remember, the function is e to the x times cosine of x. So my goodness, do not mess this up. What do you have here? You have e to the x times cosine x, right? You have a product. And in order to take the derivative of a product, you must use the product rule. Yes, you guessed it correctly, right? It's amazing how calculus makes sense. So let's go get them. So product rule. Product rule in our own words says first times the derivative of the second plus the second times the derivative of the first. So let me apply that now. So first times the derivative of the second. The derivative of cosine x is going to be negative sine x. Remember that little thing we remembered, that if you take the derivative of a trig function that begins with a c, it's going to be negative, right? Now we have plus the second factor here times the derivative of the first. And the derivative of e to the x is just e to the x, right? Easiest one in America. So there's your derivative right there. And I don't necessarily need to really spruce this up. because I'm plugging a value in it. But you know what? I'll spruce it a little bit. So I'm going to get f prime of x equals, I'm going to get negative e to the x sine x, and then plus e to the x cosine x, right? And I could factor out e to the x if I wanted to, but you know what? I don't feel like doing that right now, so I'm not gonna. So now let me answer the question. This is not the slope of the tangent line, right? This is a formula for the slopes of all the tangent lines at any point x, right? We want specifically the slope at 3 pi over 2. So that means we have to change this notation from f prime of x to f prime of 3 pi over 2. This is us evaluating the derivative specifically at x equals 3 pi over 2. So that's minus e to the 3 pi over 2 times the sine of 3 pi over 2, right? Plus e to the 3 pi over 2 times the cosine of 3 pi over 2. I'm just chucking 3 pi over 2 in wherever I see an x. So now what in God's name is the sine of 3 pi over 2? Let's go back to the unit circle, 3 pi over 2. We're now looking at the y value, right? So the sine of 3 pi over 2 is going to be negative 1. The cosine of 3 pi over 2, that's the x value, that's going to be 0. All right, so when I start to spruce this up here, all right, f prime 3 pi over 2, okay, this is negative 1. So I get negative 1 times negative, that's just e to the 3 pi over 2. And then this here worked out to be 0, right? So 0 times anything real is going to be 0. So then that's it. That's what we get. So our final answer is simply going to be e to the 3 pi over 2. All right? Call it a day. That guy was worth 2 points. So this is a 2-point question. You may have guessed that the first part was a 1-point question. All right, here we go. Let's get to C here. All right, so for this guy, let's see. It says find the absolute minimum value of f on this closed interval. Again, this is like, these are all like the basic, fundamental things that you need to learn from a calculus class. So they're testing you on that in this one question. And you can bet your life you're going to see something very similar on your 2-question test. So how do you find absolute extrema of a continuous function on the closed interval? Well, first off, how do you know the function's continuous? We should know that e to the x is a continuous function, right? We can trace that guy without lifting up our pen. And cosine x is a continuous function. And if you take 2 continuous functions and you multiply them, all right, there's a little theorem out there that says your product function is also going to be continuous. So we have a continuous function on a closed interval. So what does that tell us? All right, the extreme value theorem guarantees that we're going to have an absolute max and an absolute min. Now, because we're good calculus students, we know that the only place that can possibly happen is either critical points or at endpoints. So what do we got to do? Let's get the critical points first, since we have the endpoints, right? They gave us the closed interval. All right, it's right there. There are your endpoints. So let's go get the critical points. So we have to get the derivative. So now we kind of got the derivative 2 seconds ago, right? So I'll kind of write a little bit of this out. F of x was e to the x cosine x. But then when we took the derivative and I somewhat simplified, I didn't fully simplify, I got negative e to the x sine x plus e to the x cosine x, right? So there is my derivative. So now I have to set that equal to 0 to find my critical points. All right, so f prime of x is going to be set equal to 0. Now, if I was setting this equal to 0, I would now pull out the e to the x, and I'd probably pull out a negative e to the x, although you don't need to. I would do it. And so now I would get what? Sine x minus cosine x, and then equals 0 here, right? So I pulled out the e to the negative x. Forward multiply that, you should get that. So now why is that? Why did I want to do that? Well, because right here I have a sum, and setting sums equal to 0 is really not too desirable, right? Because you're not guaranteed that this part or this part happens to be 0, right? This could all equal, 10, and this can equal negative 10, and that would give you 0. So you don't really like having sums equal to 0, but you do like having products equal to 0. Because when you have a product equal to 0, that means either this factor is 0 and or this factor is 0, right? Each factor could be 0, because when you multiply by 0, the whole thing becomes 0, right? That's the 0 property multiplication. Now, you hopefully know that this is never going to be 0. If you take a real number like e, which is 2.7 something, and you raise it to a power, you're never going to get 0. So this can't be 0. So then the thing that you have to think about now is this. What is going to make this 0? And you got to remember, this was a non-calculated question in 2018. So how do you solve this, right? So you might just know the answer just by looking at it this way, or you might be like, oh, let me go ahead and add cosine x to both sides, however you want to look at it. The proper algebraic way to solve this, honestly, would now be to square both sides, then use a Pythagorean identity and kind of get after it. But I got to be honest, you should not be doing that. You should know what x value, what is the x value where the sine of it and the cosine of it are the same. So in other words, you need to know this, right? That memorized table. And hopefully you're thinking, oh, that's 45 degrees, right? The sine of 45 degrees is equal to, what was that? Radical 2 over 2. Like we have that memorized. And that's also the same thing as the cosine of 45 degrees. Now, I should be kind of ashamed for dropping a degree symbol in a calculus class because in high school calculus class, because we don't ever deal in degrees, right? So this is like, bleh, right? So you really shouldn't be going that way. You should be thinking the radian equivalent of 45 degrees, which is pi over 4, right? So the sine of pi over 4 is the same thing as the cosine of pi over 4, which we should know is radical 2 over 2. So that's in your brain. You're supposed to have that memorized. So now you're like, all right, so I get it, right? So in quadrant 1 here, let's draw all the quadrants. In quadrant 1, if my angle is pi over 4, then the sine and the cosine are going to be the same because this is what it's equal to. All right, but there is another value, right, in this interval 0 to 2 pi where the sine and the cosine would also be the same, right? And how would you do that? Well, I know it can't be quadrant 2, right? Remember that thing? All students take calculus, right? In quadrant 1, that means all the trig functions are positive, so then it's possible for this to happen. In quadrant 2, this can't be possible because sine is positive, cosine is negative. So you know it ain't happening in quadrant 2. In quadrant 4, cosine is positive, sine is negative. So you know it's not happening there. So then, yeah, it could happen in quadrant 3, and it would happen with the same reference angle, right? Because of that whole symmetry of the unit circle thing. So now that's not the angle, though. I drew a reference angle of pi over 4 here. What's the actual angle? The actual angle is going to rotate from that positive x-axis. It's that. So the way I like to think of it is up to this point, that's pi. I'd rather think of that as 4 pi over 4. So then, okay, 5 pi over 4 would represent that rotation there. All right, so we should know that the sine of 5 pi over 4 would be the same thing as the cosine of 5 pi over 4, which would also be the same value. In this case, it would be negative radical 2 over 2 because they both would be negative there, okay? By the way, all of this right here, this really isn't work that you would show. You wouldn't really show any of this. I'm just kind of doing that for the video. And I also didn't really get too involved in the pre-calculus stuff of reference angles and whatnot. So hopefully you're up to speed on that. The work you would show is you would get right here and you'd be like, oh, yeah, I know x is pi over 4. And then I know a reference angle of pi over 4 in quadrant 3. That would give me 5 pi over 4, right? And those are the two spots where sine and cosine are equal. All right, so now what do you have going on? You have your two critical points, which happen to both be in the interval, all right, and you have your two endpoints. All right, if I keep going around back to what would be 9 pi over 4, that's outside of 8 pi over 4, which is 2 pi. So this is it. These are the only two in this interval. So now basically what I would do is I would say, by the extreme value theorem, I know that I'm guaranteed to have an absolute max and absolute min at either an endpoint or a critical point, and now I would go ahead and test, right? So let's go ahead and test our endpoints first here. All right, so you test them in the original function. So I got to do f of 0. So that would be e to the 0 cosine of 0. E to the 0 is 1. We saw before cosine of 0 is 1. You get 1. Now I got to do f of 2 pi. So that would be e to the 2 pi cosine of 2 pi. 2 pi is coterminal with 0, so that's going to be the same value as the cosine of 0. So this is 1, but it's now 1 times e to the 2 pi. So you get e to the 2 pi. Again, this is not a calculator question. So you're like, all right, I don't know what that is. It's e to the 2 pi. Great. So now I'm going to test my critical points. Critical points. Okay. These are the endpoints. These were the critical points. So here we go. So it's going to be f of pi over 4. So that would be e to the pi over 4 times the cosine of pi over 4. All right. So the cosine of pi over 4, that's radical 2 over 2. I have that memorized. And e to the pi over 4, I have no idea what that is. I'm just going to write radical 2 over 2 times e to the pi over 4, right? Multiplication is commutative. I'm just going to write it that way. Okay, again, I have no idea what that is. And you're like, wait a minute, I'm supposed to compare this value to that value? You know, something's going to be pretty crappy here in a second. Let's see. F of 5 pi over 4. Well, that would be e to the 5 pi over 4. A little delay here in my writing. Times the cosine of 5 pi over 4, right? So like cosine of 5 pi over 4, you just talked about that. That's the same reference angle of pi over 4. That's still radical 2 over 2, but it's in the quadrant 3, so it's negative. So I get negative radical 2 over 2 e to the 5 pi over 4. And now you're excited about that, right? Because the question asks for the absolute minimum, right? So you have to compare these now. The biggest is your max, the smallest is your min. You're like, oh my God, I don't have a calculator. How am I supposed to compare these? Well, you have a positive value, and a positive value, and a negative value. So guess what? The negative is your minimum, all right? So therefore, we can say something like f has an absolute min at x equals 5 pi over 4. But what they're asking for is the actual minimum value of f. So where f of 5 pi over 4 equals minus radical 2 over 2 times e to the 5 pi over 4, right? If you looked at the scoring guidelines, the way they do this always, they make like a little table, right? They also wrote this as 1 over radical 2. If I see anyone submit their work with that, I know you basically copied the answer key because we never write it that way. We always write it as radical 2 over 2 just because that's how we happen to memorize it. Regardless, all right, so that's a good question though. All right, so to find absolute extrema of a continuous function on a closed interval, easy breezy stuff. Get your critical points, all right, and then test them and the endpoints in the original function. Biggest, max, and smallest is going to be your min, all right? So solid little question. That guy was worth 3 points, okay? So worth more than both parts A and B. All right, let's go to the next question, the next part here. All right, it says let g be a differentiable function such that g of 2 equals 0. It says the graph of g prime, the derivative of g is shown below. All right, and then it says find the value of this limit or state that it does not exist, justify your answer. All right, so you're definitely getting a question like this. So how do I do the limit of f of x over g of x as x goes to pi over 2? Remember, the first thing you should always try in a limit is to directly substitute. So if I directly substitute pi over 2 in for x, I would get f of pi over 2, right, over g of pi over 2. So you're like, all right, well, g of pi over 2, they just told me that. That was 0. F of pi over 2, well, let's see. F of x was e to the x cosine x, right? So f of pi over 2 is e to the pi over 2 cosine of pi over 2. Well, what is the cosine of pi over 2? Again, going back to the unit circle here, right? Pi over 2 cosines the x value. That's just 0. All right, so I end up getting 0 for that. All right, so bablam, what do you have? You have an indeterminate form, aka the limit is sick. What do you do when the limit is sick? You take it to the hospital. So you actually want to use L'Hopital's rule. Now, what is L'Hopital's rule? Basically, all right, it says that the limit of f of x over g of x as x goes to pi over 2, if and only if it's sick, which it is, in other words, if and only if you get an indeterminate form, you then can say that it's equal to the limit of the derivative of f divided by the derivative of g. So you're looking at basically the ratio of the two derivatives there, of the numerator and the denominator. You're taking the derivative of the numerator by itself and dividing that by the derivative of the denominator by itself. There's no quotient rule here, people. Now taking the derivative of this function. You're taking the derivative of the top and the bottom separately. And L'Hopital's rule, and we're not going to get into it or prove it right now, basically says that these limits will in fact be equal. So you're like, all right, well, let's go get them here. So let's do the easy one first. So let me directly substitute, right? So now I'm chucking in pi over 2 into my new expression, and I'll take it down over here. So now what is g prime of pi over 2? Well, I'd have to look at the graph of g prime, which is right here, and at pi over 2, its functional value is 2. So I end up getting 2 there. So I get that from the graph. F prime of pi over 2, I have to figure out. So let's recall here that f prime of x, hopefully I remember this correctly, was negative e to the x sine x plus e to the x cosine x, right? So we got that in one of the earlier parts. So if I want f prime of pi over 2, just chuck pi over 2 in it. So I get negative e to the pi over 2 sine of pi over 2 plus e to the pi over 2 cosine of pi over 2, okay? So good news here is that the cosine of pi over 2, north pole, right, x value. So I'm thinking in my head, north pole, I call it the north pole, the 0.01, right? The cosine is the x value. That's just going to be 0. So that's going to wipe out, all right? Sine of pi over 2, that's going to be 1. So I end up getting that f prime of pi over 2 is just going to be 1 times negative e to the pi over 2. So I'm going to get negative e to the pi over 2. And if I want to spruce a deuce, maybe I write negative a half e to the pi over 2. All right. And that is my answer right there. All right. So that guy was also worth, I believe, 3 points. Okay. So it's funny that I had one year a kid tell me, I did it right on the test. I did all parts A and B. I didn't really do, I didn't do many of the part C or D's. I'm like, well, that's a problem because sometimes the part C and D's are worth a lot more than the part A and B's, right? You don't know. They don't tell you this question's worth this question's worth that. So that's why you want to basically attack and give it your best on every single question, all right? Because you don't necessarily know how they're going to allocate those points. That's it. All right, so that was a great question, man. Oh, my goodness. So if you struggled with that, and I'm assuming some of you probably did, go back and redo it without the video and without my help, because there are some basic underlying concepts that you need to know, going into this test, and just really the underlying concepts of this class. Like, you shouldn't leave this class without knowing these things. All right. Hope all is well. Stay safe. Talk soon.